All right, this is lecture 1 of Algebra class, the GE courses for our AS degrees. And I am switching the microphone over to Mrs. Karen Smith. Hold on.
Hello.
Karen, are you ready?
I am.
Okay,
Yeah.
I'm switching the mic to you. Okay.
Okay. Hi, everybody.
Turn
How
on
is
your
everybody?
screen. Your screen is not on.
Oh, okay. Yes, it's coming. I'm getting that. Just a second. Let's see. Hold on. It's going to be okay. Alrighty, and show my screen. Okay. Yeah. All right. So, how is everybody today?
Your
I hope
screen is
everybody's
not showing yet.
okay. I show my screen. I clicked show my screen? So,
Now it's on. Okay.
it's up. It might have a little delay. So
Okay,
you
great.
can see.
Perfect. Thank you. I am muting myself now.
Okay. All right.
Bye.
So I sure do hope everybody is doing okay today. And I'm still kind of getting used to using GoToWebinar. So if you have your hand raised, and it takes me a while to get to you, please be patient with me, at least, our first couple of times. But let me introduce myself first, okay? Just so you guys can know who's talking to you. Who is this person, Anyway, first of all, my name is Mrs. Karen Smith, and I want to take an opportunity to welcome you to my course, our course, GE112, Algebra 1. I've been teaching algebra. I've been teaching mathematics for, I'm not going to say how many years, I don't want to date myself, but I've been teaching algebra, mathematics in higher education, and also in remedial as well, for over a decade. I'll just say that, just to be nice to myself, way over a decade. Anyway, I always look forward to the beginning of a new class, a new semester. It's a new chance, right? Regardless of how well you've done in previous semesters or in other classes, it just seems like every new semester, the new courses that go with it provide you guys and us with a fresh start. Okay, most professors and instructors, we like to meet new people. We like dealing with people. We like to help you, and that's my heart for sure. At any rate, not to go on about it, I am here and I'm available to help. I want you to know you're not alone on your journey. Mathematics sure can be one. My contact information is going to be available to you quite readily in every email and in Moodle, in the syllabus. Get in touch with me. You guys can even text message me with the number that's given to y'all. Please don't be shy about asking if you're stuck and you're confused on a topic and you've sat there for, if you've tried to work a problem out many times and you've really given it your best shot, starting to feel, like it's taking you a while, don't hesitate to ask, okay? If I think you need to try something else or whatever, I may tell you to look at it this way and go try it one more time and then come back to me. I'm not blowing you off or anything. If that happens, I want you to try. And if you see you've done that, I'm going to sit with you. I will sit with my students until they get it. It's a goal. It's to help you guys do well. I'm going to help you help yourself. At any rate, my contact information is spackled all over our website in Moodle and on all the forums, so please use it if you need me. Okay? If you were put it this way, if you're in a traditional classroom, okay, and you had a question, had a problem, you'd probably raise your hand, right? So do that, and here I probably can see the chat better than anything right now. So if you guys can chat, that's probably good. But I think that you need to get in touch with me, email me, text me, whatever you have to do. Even if you text me and ask me, when can I call you, or when can you call me, here's my number, I'll be available after 3 or something. Please let me know. I need a little help with this and that. And I may text you back saying I can call you at 5 or something to that effect. But you guys, I will find a way, and I will work with you, and I'll try to help you understand something if you're confused about it. It's my job, and I'm happy to do that. Actually, I want to do this in this pretty soon. I may post some online virtual office hours too, where you guys can just drop in. It'll be like a little hour or two in the afternoons, certain afternoons, probably Tuesdays and Thursdays, where you guys can just log on to a certain website, and I'll just kind of be sitting there at my quote-unquote virtual desk. So, you know, it'll be like a little workshopping hour. You guys can just pop in and get help if you need it to. So that's something I'm trying to implement. Anyway, I'm looking forward to working with you guys, and I hope you are too. And so let's kind of start looking at the topic today, okay? We're going to start out looking at the real numbers, okay? Working with real numbers. Okay, is everybody ready, by the way? Let me look at my questions box. Okay. All right. Let's see. Where's my attendees box? I think I got to look for hands, all right? Okay. I don't have any hands raised. Making sure. Okay. Oh, wait. Michelle. Okay. Michelle, do you still have a question? Hey, Michelle? Vella? Can you hear me? Hey, do you have a question? Okay, I don't know. Let me go to the chat. If you have a question, go ahead and type it in the chat box, and that way I'll know if it's something, and I'll catch it. And I'm gonna go ahead and start. Let's see. Wait. Let me go. I got a question right here. Okay. Okay. So I'm trying to see whose hands up. So okay. All right. Okay. Cool. So I don't see anybody with hands up. I'm going to go ahead and begin. Okay. What I want to look at. Let's see. Let me get my little notes up here. There we go. That's it. I want to take a look at the real numbers. Okay. Let me get my pen, my little drawing tool. All right. Now, let me mute everybody too. Something I need to do. Okay. Okay. Let's see. All right. Alrighty, so the message in the bottle is something that's going to be, I need to change that. So let's look at the set of real numbers, okay? And watch, I'm going to write real numbers like this with 2 lines. And there's a reason I made my R kind of fancy like that, okay? My handwriting is, this pen is kind of slippery on here, so it's kind of awkward to write at first when I haven't written on this in a long time. So be patient with me. Luckily, I can erase. Okay, so the set of real numbers is what we are going to be working within during the semester. Okay, so in other words, yes, there are unreal numbers, by the way, in case you're wondering if that question's coming up in your head, like, are there unreal numbers? Of course, numbers are real. The best way to kind of illustrate this is this way, and I've kind of minimized my my GoToWebinar box, so I'm letting you know this because I'm not going to be able to see right away if someone has a hand raised. I'll be able to see it flashing on the side, but it's harder to see. So be patient as well still, just reminding you. Okay, let me kind of scroll down here. Okay, the best way to kind of explain to you guys what's going on with this is to kind of draw a little something called a Venn diagram. So use your imagination, if you will, okay? So within this box, let's imagine all the real numbers that we're ever going to deal with are contained in this box, okay? Make this a little bigger. Okay. Excuse me, clear my throat. Alrighty, so let me label that. Let's see. These would be, okay, the set of real numbers. By the way I did my R up top with the big double stick was the way we represent real numbers. The symbol we use for real numbers would be a big fancy double-sided R, and it looks like this. Okay, double-sided, and then you do your R. That's the symbol for it, the real numbers. Okay, and so what is in the real numbers? For example, we would have numbers such as pi is 1. Let's have that. Ooh, I'm going to find my cursor every now and then. Pi, for example, would be in there. Maybe we have the natural log of 2. 3 is in there, okay? 0, negative 5.25, etc. Okay, so these are just your real numbers, okay? And actually, let me go ahead and put one more just to kind of remind you of things to come. Maybe we have the square root of 2, okay? So this is the set of real numbers. And this is not all of them, of course, so I definitely should put etc. There's infinitely many more to deal with. Okay, so those are examples of some real numbers. And inside of the real numbers, contained within, there are infinitely many more subsets. But the ones that we are going to deal with in our class are what we're going to talk about today. Okay? Now, I want to kind of show you now that, let me kind of make note of this for you. Okay, let me make this pen here. Okay, just some notations. What is a set? A set is a collection of objects, collection of elements, you could say, or objects. Okay? Sometimes people even go as far as to say it's a collection of objects that have similar attributes, and that makes sense too, but it really is just a collection of objects that we define as mathematicians, okay? And it so happens that the real numbers is kind of a naturally defined set. Okay, each object inside of a set, okay, so for example, let me go here on the side. Here's my little example. I hope my pen is not about to get crazy on me. Likes to go nuts. Okay, so here's like a little small set. I'm going to say this is the set containing A, B, and C. Okay? So inside of the set, A, B, and C are members of the set, okay? So A, B, and C are members of the set. They are the objects or the elements contained in the set. Set members. Okay? All right. Now, I can label this set, and let me go ahead and do this. I'm going to erase where I did EX there, for example. And I might want to put a title to my set. Okay, I'm going to say this is the set K for Karen. Okay, I'm going to use a capital K. So I'm going to say let the set K, and notice it's a capital letter for a set, okay, label, equal the set containing A, B, and C. Okay, so we're using capital letters to name our set. Okay, the elements enclosed in what's called braces. So these are our brackets here. These are brackets or braces. Okay, and now I can go as far as to say there is a subset. Okay, let me do this. Let's see. Okay, hold on. All right. So now I can say, make the little statement, a subset. Okay, erase that there. Okay. Alrighty. A subset of my set K. Okay. Would be okay. The set containing B and C. So you can see if all the, A set is a subset of another set if it contains members, all of its the smaller set's members are contained within the larger set. Okay, so knowing subset. Okay, let's see. Okay. Uh-oh, wait, I have to, I got my notes up here up top, so let me get this. I want to know where I'm going next. Okay, where I'm taking this. Okay, so we say that the subset of K would be B and C. And I'm going to make a little statement following that because, and I'm going to put some notation in here for you guys to introduce you to it, because B and C are elements. Now watch, okay, are elements of K, the set K. Another way I can write this, or elements of K, I can put this, okay? Let me, okay, or, in other words, or in other symbols, B, comma, C, are elements of, so it's like a curvy E, it's like a C but with the E line in the middle, of K. So what I've said here in symbolism, okay, all right, B and C are elements of K. B and C are elements of K. Now, here we go, or elements of, the symbol for or is an element of, or elements of is this, okay? So those guys match up, okay? I just want you to know that symbolism. All right, let's go back up to our real numbers. Excuse me. So within the real numbers, we have other sets, and I'm going to kind of like, I'm going to try to make this as brief as I can, go quickly on this, because I'm pretty sure you guys can handle this. It's not a hard thing, but I'm going to help you to remember. Sometimes it's hard to remember which one is which, as far as the difference between whole numbers and natural numbers. Camera racing the board there. And we're going to have a recording of this, by the way. We're going to post it. I'm going to make you guys a good YouTube video, a YouTube channel, and a playlist just for you. So you'll be able to view all this again. So if you miss anything, don't panic, okay? So here we go. So inside of the real numbers, there's a subset, okay? And I'm going to have to draw this one kind of big. Let's go here and make sure my line's going to be thick enough. Okay, there's a subset that we will call the natural numbers, okay? So here we go. I'm going to go ahead and type that in right there. And I'm going to say these are the natural numbers. Okay. All right. So the natural numbers, and let me go ahead and make that red because I want you guys to match up. Alrighty, the natural numbers we want to call the counting numbers. That's another word for the natural numbers. Okay, your counting numbers. Okay, so let me kind of put that a note of that for you right here. I guess we'll put quote unquote counting numbers. Counting numbers. Oh, I saw a message there. Okay. Okay. And the symbol for this would be a big N, okay? So we put double-sided on the left, N. Okay, and hold on one sec, guys. I have a question here. Okay, all right, I got you. So like, okay, so inside of the natural number, by the way, let me write this out. I just got up trying to wrap this part up right here, okay? So inside of the natural numbers, the set of natural numbers is this: 1, 2, 3, 4, dot, 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 okay? And when you have 3 dots in set notation, that means it goes on in that pattern, okay? So counting numbers, if you count, however you count, that's your natural numbers. So there's no 0 in there, okay? Now, let's go here now. Uh-oh, let's see. think I did this kind of backwards, actually. Okay, so I should have drawn this a little smaller. I'm going to try to make this kind of quick. So what you need to do now, let's see. Yeah, I need to do this quick. All right. I drew it too big. Sorry, guys. Please excuse me. But, okay, so now let's go here. All right. There, that's better. Okay, so now we're going to go with it. Let's do this. And so, this, okay, draw my little box. Let's go here. That's better. All right, so next up, we're working our way back up to the real numbers the way I'm doing this here. So I'm going to erase my real numbers here. I'm trying to make this quickly, do this quickly. Now, what's next outside of natural numbers would be the counting numbers, okay, or whole, excuse me, not counting numbers, I'm sorry, the whole numbers. So the set of whole numbers, these contain 0, okay? And these are really the two big important ones for today for you to remember. Of course, they're all important, and I'm just going to go ahead and write this. This is our whole numbers, okay? And the symbol for whole numbers is going to be, let's see. Sorry, let me go ahead and go down here. All right, there it is. Okay. W, you're still using W. It's kind of, sometimes there's two different symbols for a set. Next out, okay, and by the way, let's go ahead and put our 0, 1, 2, 3, dot, dot, dot. I'm making this snappy. Okay, next up, let's go to, and let me, I'm going to go ahead and make some room and do this. Let's go here. Okay. Next out, we're going to go to integers, okay? You can see this coming because we have the positives and the 0, right? So let's go ahead and draw one more outward, okay? And I'm going to kind of draw this one this way, okay? And I'm going to make note of that there on the side, and my pen. So these would be my integers now, okay? Integers. So whole numbers and natural numbers are contained within the integers, right? The symbol you use for integers is a Z, okay? Big fat Z. And of course that set looks like this: -3, -2, -1, 0, 1, 2, comma, 3, dot, dot, dot. In both directions actually would have dot, dot, dot. So we're coming up from other negatives, okay, into the positives, infinity. Okay, now it's fine and dandy until the next two I really want to talk about, and or rational and irrational numbers, okay? So I really just need to draw one more box. And so here we go. So let me get that. One more box to draw, and so these will be my rational numbers, okay? Get that. And I'm going to put this guy up top, and I'm leaving a little bit room on the side. Now I have my rational numbers. Now this is important. Open up your ears, wake up if it's been kind of boring so far. But for rational numbers, I can't draw a set, but I can define it for you. Rational numbers, let's put it this way. Any number that we can put into fraction form, okay, rational numbers. So any number, and I'm putting a little pound symbol for a hashtag for number, any number that can be put into fraction form, okay, can be expressed, let's put that, expressed as A over B. Of course, we want to say B cannot be 0. We never want 0 in the denominator, people, ever. Okay, so, and let me make a little note on the side, okay? Look about a little more about rational numbers. Okay, by the way, the symbol for that is a Q. Okay, and we use a Q. All right, put a Q on the side there. fancy Q. Okay, we need to say, okay, expressed as A over B. In that way, I want to say, okay, well, are these going to be rational numbers? For example, rational numbers, I'm going to kind of call it a rat number. Some examples would be, for example, if I would have 0.25, that's rational. Okay, let's say A over B, 0.25 is 25 hundredths, right? So we can make this decimal, we can turn it into a fraction if we need to. If you want to leave it as a fraction, you can, I mean, as a decimal, you can say we can use repeating. Also included in that, within that fraction thing, would be repeated pattern decimals. We call those repeated decimals. Okay, for example, if you see a number that, okay, of this, if we have 0. Excuse my other little accidental scribble. Let's say we have 0.656565, and it goes on forever in that fashion. Okay, one thing you might see would be 0.65 with a line drawn over the 65. Okay, what that does, okay, let's see. So this is also denoted as 0.65 with a line. The line over the 65 says this is the pattern that repeats. Okay, alrighty. So we have a the first one, 0.25, is a terminating decimal. Okay, so that's included. So terminated and repeating decimals are included in rational numbers. These are the ones that we can turn into fractions. Okay, so on that note, what is an irrational number? Well, anything except that. So if you cannot see a pattern in your decimal, or you cannot turn something into a fraction, A over B form, then it's irrational. And that would be everything else inside that real number box. So wait, let me go back up here. Okay, so everything else in this real number box that I didn't include in another rectangle. Okay, so let me come here. All right, so all this little area that's not in another thing, it's not contained in another of the rectangles, would be my irrationals. Okay, irrationals. And so let me kind of go down there at the bottom and make note of that with the yellow here. Okay, so okay, and so, all right, put that there quickly. Nope. Irrational numbers. Okay, these guys cannot be put into fractional form. Also, if it's in decimal form, it will repeat on forever with no pattern. Some examples would be square root of 2 or pi. No one really truly knows if there's a pattern, right? No pattern has been able to be conceived of yet. Okay, pi is one. The natural log of 2. It's in the real numbers, right? But it's in irrational numbers. It's the only other set it could ever be in. It can't be in one of our other major sets that we were talking about. So you may be asked to kind of try to put numbers into sets or say what set it's for. So if, let's see, on page 5 you'll be able to, that'll help you with that. So there are some other notations in that section that they'll ask you about. So I think that you guys can handle it. If you have a question or something about anything else in there, let me know. Okay, now let me go on to my time. What are we looking at now? Okay, the next thing I want to talk to you about, and let me kind of get the book there to that section. Okay, okay, yeah, okay. We want to talk about like proof, okay, mathematical proof. Let me see. Wait, no, I'm sorry, I went too far. Exponents. I want to go to exponents, and I'm going to go through some of the basic rules that you may be familiar with already. To review these in your book on page 38, you can go in and review them too, okay, you know, on your own if you missed this, but you'll also be able to review this, you know, this video. So at any rate, let me kind of get this, let me get my pen back up. Oop, okay, all right. So I'm going to page down here, make myself some room. Okay, so let's talk about exponents quickly. And I'm going to go through the basic rules, okay, the basic idea of an exponent and the basic couple of rules that will get you through just about any of the other rules, because most of the rules that as you get further on are based on these basic rules that I'm about to show you, okay? And I'll do some examples to go along with it, okay? And I'll try to make this quick because I think I may be running out of time. Okay, so the basic idea, the definition of what is an exponent is this, okay? And so let me do this guy here. I'm trying to use the same variables they use in your book so that your notation and your notes can be similar to what you see in your book. And so I'm going to do this. I'm going to say if I have x raised to the m power, okay? So the exponent in this example is m, okay? And so let me kind of make a note. Let's see. Okay. Here is my exponent, right? Or sometimes we say that's the power, right? The word for the x, the item that's being raised to whatever power, so x is being raised to the m power, we call that the base of the exponent. Remember that. These are two very important terms. You're going to have to remember this forevermore, okay? Don't ever forget this. Now, how does it work? Okay, if I have this, if I have x to the m, you know what I'm going to do is kind of get rid of this here. I need room. What this is telling me to do, repeated multiplication, right? So this is telling me to multiply x times itself. How many times? M times, right? M times. So I should write m, whatever the number m is, that many x's should be multiplied. So for example, let me come over here in blue and put an example right underneath it. For example, if I would have 4 cubed, I'm saying the exponent in this case is 3, right? And I'm going to multiply 4 times itself 3 times. So I want to write 3 4s with multiplication symbols in between. So, but remember this, you guys, if you're doing this by hand, you can only multiply 2 things at a time, of course. So look, what I'll do is carry this down. Let me get this. Yeah. Okay. So if you're doing this by hand, you would essentially, and remember this for your order of operations, you can only do 2 at a time. So first we'd go 4 times 4, 16. Bring that one down, right? And now 16 times 4. So what's that? 64. Okay? So examples, and let's see, I'm going to go ahead and I'm going to give you those rules real quick, okay? And that'll kind of get us, okay, so this is like the big number 1 here, rule number 1. Rule number 2, I'm going to start that up here. If I have 2 exponential forms, let's say m to the a times m to the b, okay, and so that rule is written like this. If I multiply 2 things that are exponent forms and the bases match, notice it's m to some power and m to some power, the bases match, then I just merely can rewrite that base and add the exponents together for my new exponent. So an example of this is this. If I have 2 cubed multiplied times, by the way, you can use a dot for the multiplication as well, times 2 to the 4th power. Notice the bases match, right? It's 2 raised to some power, 2 raised to some power. So if I have that, then my step to get me to the answer would be 2 to the 3 plus 4. Okay, or what? 2 to the 7th. Now I can put this in my calculator. Okay, by the way, how do I put that in my calculator? It's kind of simple. In your calculator, you probably would see a button that looks like this. It looks like a little rooftop. We call it a caret. So if you would type in 2 and then caret or raised, it looks like also a little up arrow, raised to the 7th. Most calculators, you put this in and then click enter or equal. You should get whatever 2 to the 7th power is. Okay, and so go ahead and try that real quickly. And let's see, let me bring that up too. I actually needed to do that myself. I'm sorry, guys. Confessions. I'm going to let you fill that in. I'm going to come back and fill it in too. And yes, I will. So, all right, sorry. To the 7th. Okay. 128 is what you should have. So hopefully that's what you got. 128. Okay, the next rule. Now I got to move quicker. Okay, next rule 3. Let's see. And really this would be 1 and 2, but since we have the definition, it's fine. It doesn't really matter. Okay, the next one I would put now, and I'm going to go back and kind of show you how there's sub-rules that you can use in these two, okay? I would like to put this one next, okay? If I have m to the a power raised to another power. So a lot of times people say this is a power to another power, okay? What happens in this case? Notice I'm not multiplying two forms with m to some power. I just have m written one time, raised to one, and whatever that is gets raised to another power. I'm raising a power to a power. I multiply my exponents, okay? So I'll have a times b is my new exponent. An example quickly would be if I have, let's say, I'm going to use a variable. Don't be afraid if you're going to start seeing variables and things, okay? It's okay. Variables are just numbers, and we can't know what they are until we can solve them. So like in this case, I just can use x as part of my answer. So I really am not interested in x right now. I'm interested in the rule, right? X is going to just wind up being my base. So I would have 3 times 2, right? Or what? For my new exponent, x to the 6th power. And we don't know what x is, right? So just like I left 128, because I did know what 2 is, if you don't know what the base is, that is your answer. Okay? So x to the 6th is as evaluated, as simplified as I can get. That's why we say simplify expressions. Okay? And so if it's all as simplified as you can make it, you know, that's the answer then in that case. Okay, some other rules I want to go into quickly. Let me kind of page down here for you. Okay, so wait up a little bit. Okay, make sure I'm looking at what I've done. Okay, so I had 3. And let me look at my time. Let's see what's the time right now. How are we doing? Okay. Okay, yeah, we got a little bit of time left. We're doing good. All right. Are we having any hands? Are there any questions? Can I see any hands raised? Everybody must be okay. Let's see. All right. I have the questions panel up. Are we having any questions about what I've done so far? Okay. Anybody got a question? I'm hanging for a sec to wait, see if there's any question. Okay, cool. All right. Okay, I'm putting all the hands back down. Okay, and so let's go ahead and put that back up. All right, cool. So now you guys have to raise your hands fresh, like again, if you have a question, okay? So next, let's go here. Let's say my next rule. Now, these rules from here on out are kind of variations, except for the, let me go ahead and put the one that wouldn't be. You can make that next. It wouldn't be a big deal. Let's go ahead and say, okay, here's this rule, 4. If you have an exponent of 0, okay, so let's say, okay, I got you. So we have m to the 0 power. This is the one that's kind of the oddball, the odd man out, that you just kind of have to memorize this one. I hate to say that, believe it or not. But if you have 0 as your exponent, then the answer is 1. Okay, so never forget that. Okay, there we go, equals 1. So look, example would be if you have, I get my pen, okay, if you have 2,335,001 raised to the 0 power, okay, this is 1. Doesn't matter what it is, okay? So anything raised to the 0 power is 1. Got that? Never forget that, okay? That's the simple one, right? And we can prove this using the very first rule. Like I said, I guess even this one is, like, they're all variations on these first few rules we taught, you saw. So now, okay, let's see. Hopefully I'm not cutting out. I see my internet's kind of getting funny. If I cut out in any part of the video, I'll go ahead and record another part for you guys. And also, if I don't get to anything, and I may decide later to do an extra video to put online from the YouTube channel, which I'll send you guys out a message to through the forums to let you know where you can get these extra examples. Okay, I think I'm going to move on because most of the other ones, the other rules are variations on this, but I think the last thing I think I would want to show you would be this, okay? Now, let's see, number 5. There is this rule, okay? If I have m over n, okay? And if I raise that to the -1, okay? What this -1 is saying is invert or take the reciprocal of. To make that -1 positive again, because you can't actually carry out an exponent until it's positive. So you'll flip the fraction, okay? Notice I just flipped the fraction over, and notice the negative exponent has become positive. So that's how you make the negative exponent positive. On that note, okay, so if we have, and I'm going to do a couple of examples with this. This goes for whichever side of the fraction is on. If I have 1 over n, okay, and let's say I want to raise this to the, okay, let's say I want to raise this to the a power, and positive a, okay? This would be 1 over n to the a, okay? On that note, a related rule for this would be this. What if I have 1 over n to the -a? Okay, so what about that? Now, how do I get that negative exponent to go positive? I flip the fraction, right? So we want, what, n over 1. And it's okay to keep your fraction, your denominator with a 1 in it for a little while until you're done. So what now? Now we know that when we have a fraction raised to an exponent, that the exponent goes into the numerator and the denominator. By the way, I could have written this earlier, right? This would end up being 1 over n to the a. So now n to the a over, I don't want to run out of room. Okay, n to the a over 1 over, excuse me, 1 to the a. Now 1 times 1 times 1, however many times, is always going to be 1. So we can, let me put some room in here. Okay, so we can write this into the a over 1, or what? Just into the a. So we can, and you don't have to write all these steps. I'm just kind of showing you the rule that 1 over n, and watch, let me shorten it up for us really nicely. Okay. How you would do it, because you would memorize it and practice it, would be this. 1 over n to the -a. Well, I know that the n, the a is going to attach itself to the n, excuse me. So I'll have 1 over n to the negative a, or what? N to the a. Okay? So anytime you have a negative exponent, long story short, if you find you've gotten yourself a negative exponent appearing in your problem, what you're going to want to do is whatever factor it's attached to moves to the other side of the fraction bar to become positive. You invert it in the fraction. Okay, now the very last related rule I'll give you, and I think we'll probably be about done today. By the way, numerical examples, I guess I will put a little extra video on there, okay? It'll be like a little supplementary video I'm going to do right after this. So this would be number 8. Just quickly, if we have a square root, let's say we have the square root of m, for example, we can write this as an exponent as well. Well, in this little indentation here, the index, what's called the index, is a 2, it's a square root. So we can write the root of the exponent, or the denominator, becomes a 2 as well. So m to the 1/2 power is a square root. Now if it's an nth root, or see, we can expand that to the nth root of m. Okay, n is our index. It's not just a square root anymore. We're not in Kansas anymore, Toto. So 1 over n would be our exponent. So this is how I can go from writing things in rational form to exponential form. So if you want to kind of write that, I'll say that again. This is a rational form to exponential or exponent form. Cool, huh? We're learning a lot today. There's so much more to learn, you guys. The best advice I can give you guys today, right now, is to start with number 1. Okay? And what I think I've shown you so far is the basis for you guys to do some good work. And it will get you started. So go on and get started. Like I said, start with the number 1 in your assignment. When you get stuck, get in touch with me. If you try it or you've looked up some things in the section you don't seem to be getting it, let me know. I'm here for you guys. I'm going to try to be as accessible as I can. And you know, please don't hesitate. I really am here for you guys, and sometimes I get bored, so like, don't be afraid to contact me. If you haven't heard from me in a while, or you're thinking you're missing your math teacher, you know, shoot me a text, send me an email, ask me a question. 9 out of 10 other people really do need to ask the question too. Okay, be the hero. All right, so I think I'm gonna call this one here with the exponents, and you guys, let me see if there's any questions. I see 1 or 2. Okay. Can you briefly summarize the difference? Okay, really quickly, can you briefly summarize the difference between determine, yes, find, evaluate, or these codes for solve? The answer to your question, Colette, is no. These are not codes for solve. Let me go over that. You know, I'm surprised I didn't even say this, and thank you for asking that. I always tell my daughter this all the time, and I tell my students as well, is that a big part of being successful in a math class is knowing what you're being asked. So you're going to be asked things like simplify, at first, simplify the expression. Okay, let me kind of, okay, so if you see simplify, well, I'm just going to write it out. Simplifying and evaluating are similar, okay? So let me kind of make this, oh, trying to go down here. There we go. Okay, directions. Understand your directions. Okay. Simplifying is for the expressions. Okay. You're evaluating, generally when you're asked to evaluate something, you're going to come out with a number answer, okay, a numerical answer. For example, I may ask you to evaluate, and I'm going to put a few little key examples quickly. I may say evaluate the square root of 100. Okay, So you would go, okay, that's just 10, right? Okay, so we would write 10. Notice the value, the word value is in here. So generally, evaluate will be some numerical or symbolically numerical, and we'll get to that when we come to it. It'll be some symbolically or numerical answer, a quantity. Okay, expressions though, okay, now evaluate, let me get here, simplify is for expressions. Okay, expressions is just one statement. There's no something equal to something. Okay, so we simplify the expression. Okay, and here's what an expression is. You got to understand what the difference between an expression and an equation is. Okay. Okay, here's an expression, 2x squared minus 1. That's an expression, okay? Or maybe another expression, I don't want to put it right next to it, but maybe negative 3x. 0 by itself is an expression. Okay, an expression just represents some number in symbolic form. Okay, we simplify these. By the way, these are simplified expressions already. We solve equations. Now, what is in the word equations? Equal. You want to solve equations. These are presented to you with an equal sign, something set equal to another thing. So, for example, 2x is set equal to 1. And it'll say solve the equation for x or solve for the variable. Are you with me? Does that help a little bit, I hope? And so we would go, what would happen with your answer in the expressions, these guys would kind of be the answers. In solving, we're solving for x. So we want to isolate x, okay? So what we do here in this case is we have 2 multiplied, so we'll divide it off on both sides, and we will get into the equation solving thing shortly. Okay, what do you do to one side? You must do the other. That's property of equality. It's like a scale that we want to remain balanced. What you do to one side, you do to the other. So we have x is equal to 1/2. Notice now I have a solution. So this when we solve equations, we need to look for a solution or something to make this statement, this equal, true. We want to keep the equality true. Is a true statement, okay? A true statement, or let's see, no, I'm sorry, is a true solution. Okay? All right, because it keeps this equality presented to you originally balanced. Okay, does that help, I hope? Okay? So as you go through each set, if you're ever confused about that, any of the directions or anything, please let me know if you have a question. Okay, so let's take a look at stuck on problem 13. Yes, I can help you. I don't know if I have time to do it right now. Let me take a look, see what I can find. So let me see, where is that? 13. Oh, okay. Okay, I can't help you with that right away, right off the bat. Let me take a look at it. And what I'll do is let's see, I'm talking to you, Stephanie. I'm going to go ahead and I'll include something similar to that in the example extra video that I'm about to do, okay? So I'm going to post something for you to help you with that, okay? Alrighty. Let's see. Hold on a sec. Go to homework assignment lecture. We can do that. I guess I didn't want to give it away, I guess is the word I'm thinking of. Okay. I want you guys to go try it. Let me look at the homework assignment. Let's take a look. Okay. Let me pull this up. I think I have one of y'all's classes pulled up already. So let's take a look. And, okay. Hold on a sec. Let me minimize this. Okay. Go out of my way. Okay, here we go. So let me get to that. Let me get this out of the way too. All right. There we are. Here it is. And there it is again. Okay, so here's our homework assignment. And we said 13, I think. Find the multiplicative inverse. Okay, what is a multiplicative inverse? Now, all that is a fancy word for reciprocal. Okay, y'all caught that? Y'all catching my drift? It's just a fancy word for reciprocal. All right. I think that was the right one, 13. Let's see. Let me see. Okay. Anybody else? Okay, so reciprocal is what? Okay, let me kind of mark up on this, okay? So let me get my, I'm going to have to get my GoToWebinar pen up. Oh, there you are, okay. Help provide some example, explain 16 and 20. Okay, I'll try to do that quickly. Okay, so multiplicative inverse, okay, if we look at that, all right. Okay, so let's take a look at 13. Multiplicative inverse, excuse me, says to take the reciprocal. So if I have A over B, of course, the reciprocal, a multiplicative inverse is basically that saying to put an exponent of -1. It just says flip the fraction, invert. Now, so the multiplicative inverse for this one, okay, and let me do an example that's similar to 13, okay? So find the multiplicative inverse. Let's say maybe I want to find the multiplicative inverse of 2x minus 1 over, oh, Lordy me, okay, 3. I didn't mean for my fraction to go out that far. So I'm going to put my little -1. That's telling me find the multiplicative inverse of this. Okay, so multiplicative inverse. Okay, so here's the deal. Okay, so what you could do for that 10 and then times y minus 1 is slap that in a big pair of brackets around that and put a -1, right? Pretend you have a fraction bar, right, and over 1, and you flip it. That's the multiplicative inverse. Now let's find it and then see, you know, when is it not going to be a real number. So let's take a look. Okay, let me get my eraser here. Okay, I can't really erase, can I? All right, so I'm just going to continue down. Just kind of ignore this, okay? We go here, and so to find the inverse, we'd say this is 3 over 2x minus 1. Oh, not 2x minus 1. Okay, let me see if I can just, no, it won't do. I'm trying to get the eraser to work, guys. I'm sorry. So let me see. Here I am. When I have to hurry, it's like I'm having one of the spaz. We'll work through it. There we go. Yay! Now here's the deal with this. What did I say earlier? I talked about never 0 in the denominator. Which thing in here would make a 0 appear in my denominator? This, right? X minus 1. Anything with a variable in it could possibly turn out to be a 0. So what x value would make x minus 1 0? Okay, that's the problem. That's what you want to figure out, okay? So right here we want to do this, okay? We want to say that x minus 1 can never be 0 and kind of solve for this and now isolate x. So in that case, add 1 to both sides of my inequality, right, my unequation. We do not want x to be 1, right? 1 minus 1 would result in a 0 in my denominator, and then the problem would blow up, right? The bomb would go off, so to speak. So this would not be a real number anymore. Okay, we want to keep it real, believe it or not to be funny, but yeah, keep it in the real numbers. So remind yourself, keep it real, no zeros in the denominator. That's only one example of what we would call a domain issue. A domain's what am I allowed to put in for x. Okay, let's see, where's my other questions? Let me see, where are your questions? Okay, I think it was 16 was one. State the sign. Okay. By the way, if x would equal 1, that's where the condition that 13 would not be a real number. All right. now, okay, let me erase all my drawings. Okay, oh boy. Okay, there y'all are. Oh, question 20. Okay, gotcha. Gotcha, Megan. I'm going to have to pick and choose here. So let me go ahead and do 20 or something similar. Okay, so it's asking us to show that something is equal to another thing. Okay, in other words, what you can do for 20 is you can show it backwards or forwards, okay? And what I'll do is I'll show you, you know, that I'm going to show you how to multiply, I guess, two polynomials. Oh, Lord, my door. The wind is starting to blow. Okay, somebody's asking me another question. Oh, no problem. No problem. You guys are very welcome. So look, I'm just going to give you a simple example to help you with 20. If you would take it starting with the right side and work your way to the left. It doesn't matter what direction you take it in, you know, you're going to take it in that direction, okay? So I'm going to say multiply these two items, okay? Okay. And so let's multiply x. All right, so let's go with x plus 2 times x squared minus 2x plus 3. The wind is blowing my door. I'm sorry, you guys. Anyway, quickly though, what we do here is we're going to take each value. First we'll start with x, and we're going to set it up as a distribution into the trinomial. We have a binomial, 2 times a trinomial, 3 terms. So we start with the x here, and it will be multiplied or distributed into the second polynomial. Then we go to the next number in the front, okay? We take that plus 2, and it also gets distributed into the same trinomial there. So we take that to get multiplied into x squared minus 2x plus 3. Okay? So just to kind of show you, remind you that this x, okay, there we go. Come on, go back. I'll go back to a pen. The x plus 2 up front is in here, but it's there, x plus 2. See, we're actually trying to distribute it in multiplying them together. It's a little system. And if you have any size polynomials, this is the way to do it. Okay? And so we'll go here now, okay? Equals, and I'm keeping it in red for time. The first one, multiplying the first one. Remember, this is a 1 implied on this x. So x to the 1 power times x squared. The very first exponent real rule we used was to, when I'm multiplying exponential forms with like bases, I'm going to add their exponent. So now I have 3 exponent x's. Now x times negative 2x, got what? X, 1 plus 1 is 2, right? Keep your sign on this 2, and we'll have x squared. Okay? Now x times positive 3, now we have a plus 3x. Okay, now let's multiply the second part of this, the plus 2. Quickly, let me try to get through this. I'm going to go ahead and just do this. I'm going to write it out. 2x squared, 2 times negative 2, negative 4x, and then plus 6. Okay, now we want to make sure you're putting this stuff in descending order, right? Descending order, that was supposed to be a 6, sorry. Okay, there you go. Descending order means I'm going to put my largest exponent up front and then do a countdown. I want to put that into descending exponent order. Okay, so the first one would be the x squared. All right, there's no other x cubed terms. Cubed is for the third power. So this is done. And look, one way to go about this, to kind of when you're combining your like terms in the end, is to kind of, once you write it down or you've accounted for it in the final answer, you can kind of just cross through it. Now, where's my square? X squared terms. These guys match up, so I can combine them. It's like saying, I owe you $2, I paid you $2. Okay, x squared is the bucks. Okay, So what you're doing is you're taking the numerical part of the exponent parts. We have these like terms, and you want to take your coefficients, the 2 and the -2, this 3, the -4, these are coefficients is the name for that, okay? You add or subtract your coefficients and just tack on the ending of the variable. Now 2 minus 2 is 0, so that kind of cancels out. Now here we have x terms, right? So these are like terms, right? The variable ending is x to the first power, right? If there's nothing there, it's considered 1. So now we have to say my coefficient of 3, coefficient of -4. I simply combine them, 3 minus 4, to get a new coefficient of -1, which I'm just writing right now to show you what's going on, and tack on the ending of x. The variable ending doesn't change. Okay, so we got that, and then plus 6, right? There's nothing I can really add to that to bring it down. Now, you would, in the end, this answer would look like this: x cubed minus x plus 6. Notice that I did not write my 1. It's understood that there is a 1 there, okay? So kind of just remember that, okay? Put that in green, making sure you know it's understood. Also, it's understood that, for example, there's a 1 as an exponent there, okay? Okay, so any other questions, you guys? I think we're pretty much out of time for now, but we will have plenty more time together, and yeah, you know, I'll try to get you guys. I'm going to look for questions. If you have more questions about the homework specifically, what I'd like for you guys to do is, in each of the units, there's something called the post-lecture discussion, which you guys have to go into for your attendance anyway. You have to make statements. The directions are in there. Each week you have to do that. But you can ask me questions about each topic, each week, each unit in there, okay? We'll keep it in each week. Ask me in the specific week that we're in. But if you have specific things like that, if it's just general, if it's something you're truly stuck on, definitely email, text me, get in touch with me, you know, as quick as you can, like that, and we'll try to get you unstuck. Okay? But yeah, if you're really stuck on like a big deal stuck, you've tried it, you need to get in touch with me quick, like call me, text me, email me quick. Other than that, though, if it's a general question or something about that unit, go in, and even if it's a question that's kind of you're not that stuck on a problem, go ahead and put it in there too. It's also an option. Post-lecture discussion, so don't neglect it. Use it. Be in touch. Let's communicate as well as we can, you guys. And I'm so happy to be your instructor. I'm here to help, and let's get through it. I know you can do it. All right. Talk to you soon. Oh, wait, let's answer a question here. Oh, you're very welcome. Very welcome. I'll talk to you guys soon.